Okay, hello grade 11s. This is just the introduction to general solutions and to specific solutions. The first couple I'm going to do are quite easy, and then there'll be a follow-up video from this with more difficult examples. Okay, so basically when you are finding a general solution, it's kind of like a little formula that tells you all the places where this is true. Okay, it sounds a bit weird, but I will show you what you need to do. I've written some steps here at the bottom that really help you. First things first, make sure that you have a cost diagram on the side, just so you can see. Remember 0, 90, 180, 270, 360. But essentially what's important here is to know where cos and tan and sine are negative and positive. Okay. So basically you're trying to solve for this generally. Okay, so what that means is when you start, you're going to have to make sure that you get sine x on its own. Basically you're solving for this angle, so you follow your same steps as you normally would. So you're going to get sine x equals, if I take the 2 over, it becomes sine x equals a half. Okay. So once you're done doing that, what you're going to do, your next step is called finding the reference angle. So you're going to find for me what the reference angle is, okay? So that involves using your calculator. So you do as you normally do. You shift sine of a half to get your reference angle, which turns out to be 30. So your reference angle here is 30. And you'll see when we get to this example, no matter whether this is positive or negative, you're going to shift of the positive version of it. The positive or negative just tells us which quadrant, which we're now going to cover in this step. Okay, so once you've got your reference angle, you're going to find a solution for two different places. Okay, if you look over here, sine x equals a half. So clearly sine is positive. So you need to tell me which quadrants are is sine positive. Sine is going to be positive in the first quadrant and in the second quadrant. So your two solutions, the one is going to be in the first quadrant and the other one is going to be in the second quadrant. Okay, so let's just write these in so that you guys remember them. Remember, this is 180 minus x, this is 180 plus x, this is 360 minus x, this is just x. Okay. Alright, so for your first quadrant, you notice it's just x, it's just the angle. Whatever it was from here to wherever this line is, it's just x. So x is going to be equal to 30, which is your reference angle. Okay, and then your final step, which I'll show you, I've written here at the bottom, is you're going to say plus or minus K360. Okay, and I'll show you why we do that. Okay. So it basically means 360 degrees. If you can imagine, if we have a line here, let's just say this is x, and I go around 360, I'm taken back to where I started. Okay, but just understand, and I'll explain this in more detail, that you will only use 360 for sine and cos. So if you guys remember your sine and cos graphs, remember kind of looks like this. So this would be your sine graph, and this would be 360, this would be 90, 180, and this would be 270. So your full graph repeats every 360 degrees. Whereas remember, when you're doing a tan graph, this is 90, 180 and 270. Your tan graph looks like that. It repeats itself every 180 degrees. So for sine and cos, you're going to plus K360, and for tan, you're going to plus K180. Okay, it's always going to be like that. Alright, so this over here is the general solution in the first quadrant. Okay, then we need to make another one for the second quadrant because it is also positive over there. Okay, so what you're going to do is you write down again x equals, and then over here you're going to have 180 minus x. So it's 180 minus, and then you replace x with your reference angle, which is 30. And then you still have plus minus k 360. Why 360? Because it is sine, and sine repeats itself every 360. So x equals 180 minus 30, which is 150, plus minus k 360. Okay, so you're probably asking yourself, what does the k mean? The k just represents whole numbers, and you'll see why we do this for our specific solutions. You replace the k. It's a variable, so you can replace it with 0, 1, 2, or -1, -2 to find your specific solutions. So like this would be your first solution to this. Sine is a half at 30. But in 360 degrees on your graph, it's going to be a half again. And in another 360 degrees, it's going to be a half again. You understand what I'm saying? Okay, so these are your two different general solutions for sine x equals a half. So just to run through the steps, what you need to do, step 1, isolate sine, cos, or tan. So like we did over here, we got sine by itself. We said sine x equals a half. We got it alone. Then you find your reference angle. How do I do that? I shift of that half. And if it was negative, I would still shift the positive half. The negative only tells me which quadrant I'm in. Okay, then your third step is to ask yourself which quadrant. So we checked where was it positive. So it's in quadrant 1 and quadrant 2. So I'll always have two different little general solutions. Okay, so for this one, like we said, it was quadrant 1 and quadrant 2. And then once we decided quadrant 2, you use your 180 minus and you replace that x with your reference angle. And your final step is plus minus k360 for sine and cos, but for tan we would use k180. Okay, so let's go and do example 2. So what's my first step? I want to isolate the tan. So I'm going to say 3 tan x equals -4. I take the 4 over. Then I do tan x equals -4 over 3. Okay, so remember, this negative only tells us which quadrant we're in. It doesn't, we don't use it when we're taking the reference angle. Okay, so I'm just going to draw this over here to remind myself. Okay, so the next step, step 2, is to find your reference angle. Your reference angle equals shift tan 4 over 3, which is 53,13. Okay, so that is just my reference angle. Okay, now we need to go and decide which quadrant. So where is tan negative? Tan is negative in quadrant 2 and quadrant 4. Remember, this is 180 minus x, and this is 360 minus x. Okay, so you know you're going to have a solution for quadrant 2 and a general solution for quadrant 4. Okay, so for quadrant 2, remember it's 180 minus, so we start by saying x equals 180 minus 53,13. Then you still need plus minus k 180. Sorry, should have made more space there. Anyway, so 180 minus 53 plus minus k 180. Why 180? Because it is tan. Tan repeats itself every 180 degrees. That's how the tan graph looks. The sine and the cos repeats itself every 360. Okay, so therefore x equals, and we can check, 180 minus 53.13 is going to be 126,87. 126,87, and then it's plus minus k 180. Okay, alright, then for quadrant 4 I need to do the same thing. So I need to say x equals, but now it's going to be 360 minus x plus minus k 180. So x is equal to 360. Sorry, I should have actually replaced the x with, let's just write it over here so I don't feel like wasting space. 53,13. Sorry, instead of the x, write 53,13 because that is your reference angle. So 360 minus 53,13, which is 306,87. Then you will still have plus or minus k 180. Okay, so those are your two general solutions for tan x equals negative 4 over 3. So again, to run through the steps, you isolate sine, cos, or tan. You then find your reference angle. You take, just remember here, positive. You take the positive version of whatever it is. Then you ask yourself which quadrant, which that sign will then enable you to do. And then right at the end, you add plus or minus k360 or k180, depending on whether it is sine or tan or cos. Okay. Alright. Now, they may ask you for specific solutions, or they will ask you for specific solutions. For specific solutions, you use your general solution to come up with your specific solutions. So they will tell you the interval. Okay, so they'll say give the specific solutions between, like for example, between 0 and 360 degrees. Okay, so they will always tell you, and then what you do is you're going to find your answers. If it falls outside that interval, you don't give it as an answer, but if it does fall within the interval, you give it as an answer. So, for example 1 that we just did, here's example 1. I'm just going to write it down. So our two solutions was x equals 30 plus minus k360, and our other solution was x equals 150 plus minus k360. Okay, this one's going to work out quite easily. So what you're going to do is you're going to start by replacing k with 0, then 1, then 2, etc., etc. That's why I've got that plus minus. It doesn't really matter, but essentially you're first going to plus 360, then you're going to plus 2 times 360, then you're going to plus 3 times 360, and then you're going to do minusing. Okay, so for this specific one, let's look at the first solution. If I look at this one, okay, I'm going to say x equals 30 plus minus, now let's start with 0. So it's 0 times 360. X is going to equal 30 degrees. Does 30 fall between 0 and 360? Yes. So that is one of my specific solutions. Okay, let's go and try and replace it with a 1. Okay, so let's say x equals 30 plus 1 times 360. Okay, so x equals 30 plus 360, which is 390. Does that fall within there? No, so it's not going to work. I'm obviously not going to put any higher values because it's just going to keep getting bigger and bigger, and we want it between 0 and 360. If you do the opposite, if you minus it, if you say x equals 30 minus 1 times 360, clearly that's going to be negative, and we are trying to get between 0 and 360, so that doesn't work either. So this is the only one that works from this solution. Let's try and do this one. So x equals 150 plus minus k360. Let's replace it with the 0. 150 plus minus 0 times 360, which is just 150. Does 150 fall in there? Yes, it does. Okay, if I take 150 and I add 360, clearly it's going to be bigger than 360. If I say 150 minus 360, it's going to be negative. So my only specific solutions here is x equals 30 and x equals 150. Okay, so for specific solutions, it's very easy. Like I said, they give you an interval, and you just replace the k with numbers and check basically if it falls within that interval. If it does, then it is one of the specific solutions. Okay, wasn't sure if this was part of video 2, but I think I'm going to do it now. Okay, so remember your steps. So now I want you to continue what we did with the first one, coming up with a general solution. So remember, what did we do? We isolated the sine, cos, and tan. We found the reference angle, which quadrant, blah, 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 blah. So just because this has stuff within this bracket, nothing changes. You're still going to go and isolate the sine and then find the reference. So sine x plus 20 is going to equal square root 3. If I take the 2 that side, it's square root 3 over 2. Okay, now just like you used to do in grade 10, when you shift this whole thing, x plus 20 is going to equal the reference angle. So just be careful. So your reference angle, x plus 20 equals, the whole thing in the bracket equals, shift sine root 3 over 2. So that is 60. So x plus 20 equals 60. Okay. In this particular case, it doesn't matter. You could take the 20 over now, but it does matter when you have like a number in front of the x. You need to kind of save it until the end because you would have to divide the K360 and the K180. But I will try and show you a specific example of that. But just to keep consistency, I'm going to do all of these by carrying this whole thing down. So what I mean by that, I think I'm talking in the air a little bit too much. Okay, so we're looking, root 3 over 2 is clearly positive, so we're working in 1 and 2. So I'm going to have this general solution for 1 and a general solution for 2. So for 1, remember this is just x, this is 180 minus x. So for x, it's going to be x equals just the angle, which is, sorry, yeah, I just said I was going to do it in a minute, sorry. So x plus 20 equals, then we just use the reference angle, which is 60, and then it's plus minus K360. K360 because it is sine. Now you can take your 20 over. So x equals 60 minus 20, which is 40. Okay, I know you're asking, you could do it this way. You could take the 20 over there, but I just want to keep some consistency so you just remember, just rather do it in one step in the next line, because when it comes to dividing, if there was like a 2 in front of there, you would have had to divide the 360 by 2 as well, not just the angle. Okay. Alright, so that's your first solution. Your second solution, remember, it's 180 minus. So now you've got x plus 20 equals 180 minus 60. Remember, you replace the x with your reference angle, plus minus K360. Now you can work it out. So x plus 20 equals 180 minus 60, which is 120, plus minus K360. And then you can take your 20 over. So it's 100 plus minus K360. Okay, just to try and make sure I've explained what I was trying to explain. Let's say, for example, what was in this bracket was, I don't know, 2x plus 10. Let's say that was in the bracket. Okay, and then I found my reference angle. I got to this point and my reference angle was 20. Okay, you can't just do this. You can't just say, okay, 2x equals 10 divided x is 5, and then say, okay, x equals 5 plus minus K360. That is incorrect. Okay, what you would need to do is say 2x plus 10 equals 20 plus minus K360. Then take it over, so 2x equals 10 plus minus K360. Then when you divide it by this 2, you're going to get 5 plus minus K180. Do you see what happened over there? That's why I'm saying rather carry this down and then only minus afterwards. Okay, cool. Example 4. So we need to get the cos alone. So I'm going to have 3 cos x minus 25 equals minus 2. So I take the 2 over. Then I have cos x minus 25 equals negative 2 over 3. Okay, so now I have the cos alone. That's perfect. Now I just need to go and figure out here which quadrant. Where is cos negative? Cos is negative in 2 and 3. this being 180 minus x, that being 180 plus x. Okay, so now I need to find my reference angle. Remember, I take the positive version. So x minus 25, the whole angle there, equals shift cos of 2 over 3, which is 48,19. Okay, now I'm going to go and check which quadrant. We said quadrant 2 and quadrant 3. Okay, so over here, x minus 25, that's my whole angle, equals 180 minus my reference angle, which is 48,19. I'm just going to write under here, plus minus k 360. Okay, so x minus 25 equals 180 minus 48,19, which is 131,81 plus minus k 360. Okay, then I can now take the 25 over. So x equals that 131,85 plus 25, which is 156,81 plus minus k 360. Alright, so that's the solution for quadrant 2. Then we must still do the same thing for quadrant 3. Remember, it's 180 plus x. So go back to your reference angle. So x minus 25 equals 180 plus, and then your reference angle is 48,19 plus minus k 360. So x minus 25 equals 180 plus 48,19 to 28,19 plus minus k 360. Then take your 25 over. So x equals that plus 25, which is 253,19 plus minus k 360. Okay, so these are your two general solutions for this one. So just bear in mind, there's seriously hardly any difference between these kinds where there's just an x and these kinds where there's things in between here. All you do, you find your reference angle as per normal, then you make this equal to whatever the story is, if it's like 180 minus or 180 plus k 360, and then you just solve for x. Then just remember for this, if they ask for general solutions, and if they ask between a specific ratio, you just fill your k with 0, 1, 2, 3, 4. Check if those solutions fall within that interval. Okay, thanks grade 11s. I hope that you understand this work.